Hello everyone, welcome back to the channel. I hope you guys are doing really amazing. We will see today's daily challenge on Leetcode and try to solve it together. And definitely for today's video, it is a little off-topic video and it does not belongs to any kind of data structure. Okay, so you just need your intuition and imagination to solve this. Okay, so the concepts involved is only intuition. Let's try to see what is happening in the question at first. Let's try to understand the question. So you are given an integer array cards of length 4. You have 4 cards, each containing the number in the range 1 to 9. And so you are basically given 4 numbers from 1 to 9. And you should arrange the numbers on these cards in a mathematical expression using these 4 operators only and also a parenthesis. Okay, two kinds of parenthesis to get the value 24. Okay, so no matter what kind of operations you performed in those 4 numbers, they must have this value of 24. So that's what is asked in this question, and you are restricted with some of the following rules, like the division operator represents the real division and not the integer division which we do. So if you see in this example, 2 by 3 is actually 1 by 2 by 3 is actually 0.67. Okay, but in integer division it's 0. So if you would have followed integer division, you would have got 1 minus 0 and 4 by 1 answer should have been 4. But since it is 0.67, you subtract it from 1 to get 0.33, and 4 divided by 0.33 is nothing but 12. Okay, so that's how this division operator should work here. So while doing you should remember to use double and not integer data type. Okay, otherwise the division will be flawed. Okay, now every operation is done between two numbers. Okay, so you are allowed to perform operations between two numbers only. There are no unary operators allowed. That is -1 cannot exist with itself. Okay, so in other words, if you are given 4 numbers, you can perform 3 operations. Okay, in 3 operations you will just reach the answer. Okay, so that's what they are telling here. And you cannot concatenate numbers together. That's quite obvious. You are given separate numbers, why would you ever concatenate them? And you return true if such an expression evaluates to 24, otherwise you just return false. And you can see in this case that if cards are like 4 numbers which are given to you is 4187, you can reach the value of 24 by 8 minus 4 and 7 minus 1, which will give you the value of 24. And this cards is 1212. If it's like answer will be false, because in no way you can reach 24, and it is told that the length of this array will always be 4. That's, you are given 4 numbers and those numbers will always lie within 1 to 9. So you can perform the best possible brute force solution. Okay, no one is stopping you to perform any kind of brute force, yes, because the time constant is practically, I mean, it's just O of 1. Okay, it's just O of 1 no matter how you perform. So there is no n actually involved there. So the thing is that how will you perform even in brute force manner? Okay, so at first I know this problem might look very off topic and very difficult to you if you have not done similar problems before, but let's try to break down into some algorithms. Okay, so what we are having is that we are having 4 numbers given at first, a b c d, right? So and you are performing operations between them. So you place these 4 numbers side by side. Okay, so what I am doing is that I'm just placing these numbers side by side. What you can do, you can choose any two numbers which are side by side and perform an operations between them. Okay, so after performing operations, you will be remaining with 3 numbers, a dash, b dash, c dash. Okay, so let's say you performed an operation between B and C, then your A becomes A dash, B, that operation, let's say B, some operations you performed between B and C, that becomes B dash, and this D becomes C dash. So I hope you understand what I'm trying to say. Your initially you have 4 numbers, okay, and by performing operations you got reduced to 3 numbers. You can perform the operations in any way, right? And in this also you can select 2 numbers side by side and you will get another 2 numbers, a double dash, b double dash. Okay, and now you have reduced your number of numbers to 2 and you perform again any 4 kind of operations, and each step you are performing any 4 operations. Okay, any 4 operations among plus, minus, multiply, divide. Okay, so I hope you do get that. uh, then again any 4 operations you are performing, then again you are performing any 4 operations, and the result you should get, the result which you got here, that should be equal to 24, or you can also say that result minus 24 should be a very small value, like let's say 1 minus 5. So I hope you get a little hint of how to solve this problem. So what you need to do is that let's try to frame some proper algorithm. Okay, so what can be our algorithm? Okay, start with 4 numbers. You have started with 4 numbers, right? Started with 4 numbers, and so perform any such operation, any operation between any adjacent elements, any adjacent elements. Okay, uh, so your now you have, after performing this, now you have 3 numbers. Okay, so if this is step 1, so now you just repeat step 1, again you perform any operations between any adjacent element. Okay, now you have now for 2 numbers. I hope you understand it. You now are having just 2 numbers, and you just repeat this step 1 again, step 1 again. Now you have 1 number that should be 24. Okay, should be as close to 24 as possible. So this is the algorithm which you can think of, and you need to repeat this algorithm. So there is another thing you need to observe is that you are performing operations between only adjacent elements, because if you place elements side by side, there is no other choice, right? You can only perform operations within the adjacent elements. So A, B, you are ignoring the cases where you can perform the first operation between A and D. So what you do is that you repeat all of these through all possible permutations. Okay, all possible permutations. You repeat this through all possible permutations. So what you do is that the first permutation may be A, B, C, D. Second permutation may be A, C, D, B, something like this, anything. Okay, so I hope you know a function in C++. I hope in whichever language you are using, there will be some function already inbuilt which will generate permutation. Okay, so in C++ we will use the function next permutation. If you don't know that in your particular language which you are following, what is the which generate, I mean what is the function which generates next permutations, so you can just Google it out or ask ChatGPT or whatever. This is the next permutation which you need to do. And so basically this whole algorithm which I have written, this whole algorithm, you just repeat it for uh, all possible permutations. Okay, you just repeat it out for all possible permutations, and if ever you get something which is, I mean, in any permutation, if you get a valid number means 24, you just return true, otherwise you return false, right? So I hope this was clear to you, and I just for C++ users, as I will be using that, I will just show you that what is the function of this next permutation exactly. So what it does is that uh, it arranges, so it takes an input of like vector dot begin. Okay, vector dot begin and vector dot end. Okay, vector dot end. So what it basically outputs is that next lexicographically largest, it just outputs next lexicographically largest permutation. Okay, and it arranges the vector in itself. It takes the vector iterators begin and end, and it arranges the vector itself into the next lexicographically largest permutations. And what it can do is that it returns true. It returns true if it is possible. If it is possible to arrange, it returns true. If it is possible to arrange, otherwise false. Okay, so you might think that in which case it will give false. So let's say you are having an array where the array is like 9 6 2 1. Okay, in this case you see it is already lexicographically largest. There exists no possible permutation which is next lexicographically largest. I guess you understood it easily. So this is the case where it will stop. So what I can do, I can start with 1 2 6 9. I can sort the whole array and I can perform next permutation. I can just perform the next permutation, keep performing this next permutation unless I get the uh, reverse sorted array. Okay, and in between all these I will get all possible permutations, and in every possible permutation I will apply this whole algorithms. I will perform any operations between any adjacent elements. Okay, so now how exactly will this work? So let's try to code it out, only then only you will understand. So at first we will write some bool is valid function. Okay, so it will just take the number. I will performing the permutation part later. I will just I will just write the algorithm which I told you at first. So it will just take a particular permutation of cards. Okay, it takes a particular permutation of cards and it just tells you whether you can form 24 with it or not. Okay, so I will take numbers like A, B, C, D. Okay, so A will be cards of 0, B will be cards of 1, C will be cards of 2, and D will be cards of 3. So I hope you understand that I extracted the numbers A, B, C, D from it, and I definitely stored it in the form of double, because in the while performing division you need the exact answer. Okay. So what I do now, what I will do now, I will write something like is valid. I will write another is valid function, and this is valid function, unlike this one, this takes a vector. This will take three integers, because when you have four numbers and you perform one operation you get three numbers, right? So perform any operations between any adjacent elements and now you have three numbers. So first adjacent elements is A and B, so you can perform any operations between these A and B. Okay, and okay, so I hope you understand what I am trying to do now. So I will just copy this four times. Why did I copy? This is because I have four operations: A plus B, A minus B, A into B, and A divided by B. So that's why I just do it and return true for this. Okay, so let me just do it like this. Okay, so I hope you understand what I am trying to do is that the first adjacent of I'm just performing this first step. Perform any operation between any adjacent element. So the first adjacent element is A and B, and I'm performing any four operations between them, and I will do the same again and again. So what I will do here is that I can just do B plus C. Okay, I can do B minus C, and in the same way I can just do B into C, and in the same way I can just do B divided by C. Now in the last thing I can just do A, B, C plus D. I can do A, B, C minus D. I can do A, B, C into D, and I can do A, B, C divided by D. So I hope you understand that between all possible adjacent elements A, B, B, C and C, D, I performed all the four operations, and if it returns true then true, otherwise return false. But I need to write another is valid function. I hope you understand that's why, because this will take three integers only this time, not four integers. So it has only three integers, double A, double B and double C. Okay, so I hope you understand it now. And if it's like is valid, I will do the same thing again. So I hope this thing is becoming now really clear and easy for you. You have just three integers. Now if you perform an operation you will get two integers remaining, right? So I just copy this, and it will be I have only A, B and C, so I have no occurrence of D in my whole of the function. So I will just remove my D. Okay, I will just remove this D. So yeah, I just take this D and just remove it, and I hope you understand it. Return false. But you see this A by B cannot be 0, right? Okay, so we do B, and here C cannot be 0 since it is getting divided by, so we do C. And why would we not do something like this here? Because it is already given in the question that the initial numbers are from 1 to 9, they cannot be 0, but after performing some operations they can be 0 in the subtraction, right? So we just make sure that they are not 0 in this manner. Okay, if they are 0, then do not perform this valid operation. So I hope you also get it very easily right now. And now you have this final function. In this function you must ensure that you take two integers, because now you have already performed two operations and you have reduced the number of integers to 2. So after you are having these two numbers, what you will do is that you will perform similar things, a minus b, but you see they should be 24, right? So minus 24 should be less than or equals to 1e minus 5. That's a very small number, and this can be negative also, so let's have an absolute value. And that is all, I guess. That is all. You just copy this thing 4 times. You have only two numbers here. Okay, so you just copy this thing 4 times and you do the same thing again. A minus b, a into b, a by b, and you also make sure that b is not 0 again here. And yeah, if this is true, just return true. There's no doubt about that. And if it's false, just return false. So you see, you perform this whole algorithms, perform any operations between any adjacent elements. Now you have three numbers, repeat one. You have two numbers, repeat one. You have one number, and this should be 24. That is, its difference with 24 should be very small. So I hope you till this portion it is very clear to you. Okay, so now this same function definition does not matter if the number of arguments is different. So if you know this object oriented languages, so there is something called operator overloading. So if there is the same function definition and if the arguments are different, then the compiler easily understands which function to calculate. So you don't need to worry about that, or you even don't need to do something like valid 2, valid 3, something like that. You don't need to change the function. So this whole algorithm should be repeated over all possible permutations, right? So what I can do easily is that I told you that first I can just sort this number and keep performing next permutations till I keep getting the next lexicographically largest permutation. Okay, so what I will do is that if I will just sort this. Okay, so sort cards dot begin, and I just do sort cards dot end. So just perform this. Now I also just check that after performing this, if is valid of cards, then you will just return true. And now while next permutation, you perform this next permutation, which is an inbuilt function in C++. So I will just use this next permutation. What is the argument that it takes? It takes the pointers which are pointing to the first and last element. So while this is true, while you can get a next permutation, what you do, you just check that if is valid of this cards is true, then return true at any time, and otherwise you just return false. So this is valid function is called over all possible permutations. So for instance, if the three numbers were something like 1, 2 and 3 arranged, the next greater permutation, next lexicographically largest permutation will be 1, 3 and 2. Next lexicographically largest will be something like 2, 1, 3, and so on. It will go on until it will reach 3, 2, 1. Okay, so I hope you understand this next permutation thing. You can also write a function to, if you know next permutation question on Leetcode, there is a famous question on it. You can just go and implement it on your own also. The time complexity is same, just that if you use the library representation, it will be more optimal. So I just use this, and I hope this thing is very clear to you. It is not at all difficult, this problem. Okay, if you are thinking in the correct manner, otherwise this may look very scary to you. So yeah, I hope you understood what do we need to do. Let's try to run it and check if it really works or not. Okay, so you see, let's debug this return false. I missed a semicolon here. So try to run it now. You see we are getting the accepted thing. If we try to submit it and check, will we get the correct thing still? Yeah, so you see we get the correct thing, and our runtime is 100% beats. Memory is also very less, 99.78%. So you do understand that we are using very less memory and time. So I hope this question was very clear to you. If you learned something new from my video, definitely like and subscribe. Okay, so it gives me motivation to put more effort in making such videos. So yeah, that's all, I guess. That's all for today. I hope your day goes really easy and not as hard as this problem. Thank you so much.